going to introduce the presentation, which was at my request, which was STIC, because STIC is one of those technologies that burst onto the market in the early 2000s, about 15, 20 years ago. Everyone got very excited, and then everyone got very unexcited, or a lot of people got very unexcited because it was just possibly a bit too complex to use. But actually, it's a really interesting technology, and I'm trying to get good at it. So, Peter, over to you.
Yeah, no, thank you very much, and thank you also for the request to do more explanation, a deeper explanation of the technology STIC. STIC stands for Spatial Temporal Image Correlation, so that means that you make a 3D sweep to the fetal heart, and we know that in the beginning you saw a lot of publications coming on of the STIC, but also then we noticed as Voluson also the engineers also said there could be a bit of a time pressure, of course, when you make a STIC. So, of course, you have the breathing of the mother, you have the baby that can move. So, but now, and especially that's also what Roland will explain, that the time component, we could really reduce it with a new technology, with an electronic probe that's called the EM6C probe. I think you got a bit of experience also with this new probe. So these new probes, for example, can do a acquisition of a STIC, so that's called electronic STIC, in around 3 seconds. So that means that the time component of getting this acquisition fast, but also you see a big increase in image quality, especially in the P plane and the C plane, as I explained also in the first MDT that about the planes that we can get. But also what is a very interesting technology, of course, when you store the STIC acquisition, you have exactly 1 heartbeat. And afterwards, you can do a lot of as you do with the 3D technology. You can, for example, render, you can place dot in different directions, but also, for example, the B-plane technology of the electronic probe is a very valuable technology, because what you get, for example, when you make a 4-chamber view, and you want to have the septum also directly in a 90 degrees angle, you just place a line and then automatically you get a B-plane. So this is all possible with an electronic probe on the Voluson XP22. But let's move on to the explanation from Roland, so we can have a look what Roland is explaining when it comes to STIC on the Voluson XP22. So thank you.
So now I would like to give you some information on STIC and e-STIC. I will divide this in 2 parts. The first part will be a technical presentation, how to do STIC and what are the basics of STIC, followed by a reloaded data volume on an XP22. So STIC stands for Spatial Temporal Image Correlation. And what are the different ways to acquire volume of the fetal heart? Of course, the first one is a static 3D, which is, let's say, really a fast acquisition with almost no motion artifacts, because we have a very small volume box and a small volume angle. And this allows you now to do some morphological assessments of the chambers and of outflow tracts. The second way to acquire or to examine the fetal heart is real-time 4D. Let's say it's a normal 4D acquisition with a very small elevation angle with around 20 degrees in a mid quality, which gives you now a very high volume rate, up to 25-30 volumes per second, which allows you now to do some morphological assessment of the chambers and outflow tracts in real time. Now the next step will be STIC. STIC and e-STIC, and how does it work? So, you know, on STIC you have to set up the system and give the system some information what is needed. For example, the acquisition time, which can be selected between 7.5 and 15 seconds. Then you should choose the correct volume angle, which means you should have a volume angle 5 degrees more than the gestational age, and a high quality. After that, this can be combined with multiple features and rendering modes like TUI, like B-flow, inversion, glass body, and so on. So what are the different steps now to acquire volume? You can see it already in this video. So the heart is beating, you acquire volume, and after that you have an information which looks similar to an M mode, which are the different heart cycles. Now the system starts to evaluate the fetal heart rate, and there is a special compression now, which is the so-called wavelet compression, which can reduce the data size but increase let's say, the quality. What does it mean now? Now the system will rearrange all those stored images in those heart cycles. That means from heart cycle number 1, image number 1 will move to a memory. Heart cycle number 2, also the image number 1 will go to the same memory. Heart cycle number 3, also image number 1 to the same memory. And this happens with image number 2, 3, 4, and 5, which looks like then that you have one pot with images number 1, number 2, 3, and 4. We'll take out the best images out of it, and the result is 40 volumes arranged in one heart cycle in an endless loop. Now the next part will be STIC. Let's say the basis is the same as we do it with STIC. So that means we acquire volume, a rearrangement of images of image number 1, 2, 3, and so on. But there are some advantages what we have now. The first one is a very fast acquisition time between 1.5 and 3 seconds, and really less movement artifacts, an automatic detection of the fetal heart rate, but the same also as it is in STIC, 5 degrees more than the gestational age, and the result will be really high definition images in all the 3 planes. Also here you can do a combination in for all other modes like TUI, B-flow inversion, minimum mode, and so on. Now just simply a comparison. Of course the normal STIC is an excellent image quality, but still you have some movement artifacts. In STIC it's a little bit higher, especially when it comes to multiplanar imaging, when you look to the A, to the B, and C plane with a very, very high image quality in all the 3 planes. By the way, STIC, it's just available on an E10 or on an Expert 22. And now I would like to move over to the system and reload one volume to give you some tips and tricks how to do it. So now I would like to show you a few things on the stored volume acquired with the EM6C probe. Only with the EM6C probe it's possible to do an STIC. So here we have now a multiplanar volume in a cine loop. So what you can do here, you can do some improvements. First of all, I would lower the speed. So this is easier then to work with the volume. And to improve image quality, I would add the VCI, the volume contrast imaging. The next step, what I would do is I would do a parallel shift going through the volume to have a look to the complete stored volume if everything is in the volume what you were expected. Scrolling a little bit higher, showing you in the A plane the so-called 5-chamber view, going further, and the 3-vessel trachea view, and going back again. Of course, now you could also do a parallel shift in the C plane. You go lower, up again to the apex of the heart, and be sure everything is in the volume what you would like to have. And also this parallel shift helps you to orientate in the volume. Let's go back. When we talk about orientation and you start to rotate around X, Y, Z axis and you get lost, simply press the init button, which brings you back then to the start point where you are exactly after the acquisition. So now, what can we do now? For example, I would like to show you the aortic arch, which is quite easy to do. In the A plane, we can see the cross section of the aorta. Place your dot into the aorta. Be sure in the C plane everything is vertical orientated. That means everything is absolutely vertical. The aorta is vertical, and in the B plane you can see then the aorta and the aorta coming out, the so-called aortic arch. Back to the init button on the beginning. So what else can we do? Of course, we could now render the fetal heart. First of all, when I press render, you see now immediately in the fetal cardiac setting, the render direction is from front to back. Why? Because we would like to see the heart from front to the back side. And immediately in the B plane, you can see a kind of 4-chamber view, but this can be improved. First of all, change the render box in the C plane to get also the information of the thorax, also in the B plane. And now simply move in the B plane your volume inside the render box, and you see now the 4-chamber view. You can go a little bit higher to the 5-chamber view, going further, and we are again out of the heart and inside the heart. Another nice tip would be, instead of having a straight render box, you can curve the render box. Around the trackball you can see here the curve button. You curve it, and this gives you kind of better depth impression. So again, now I move outside of the heart, inside to the so-called 5-chamber view, going lower to the 4-chamber view. So this is the first thing what I could do here. Now let's go back to the multiplanar init button, back to the beginning. What we could do now, for example, we could like to, or we could show the septum in a very nice and simple way. First of all, again, activate the VCI. Place the dot in the A plane on the septum, similar to the aortic arch technique, rotate it around the Z-axis, and immediately in the B plane you can see now the complete septum. And imagine if there would be a VSD, this could be visualized immediately. Now let's go to the next part, to the rendering. So we press render, and now we have seen before the 4-chamber view and the 5-chamber view. Now I would like to see in the rendered image the septum and the valves, the tricuspid and the mitral valve. So therefore we change now the render direction from, instead of front back, we go now to up down. And you see what happens here now. I change now my render box. I do not need anymore the curved render box. The only thing what I have to do now is I rotate in the A plane. For example, now I would like to see the valves. Make it horizontal in the A plane, parallel to the valves, the green line. Change the render box in the B plane. And what can we see now? Very nicely, from the apex direction, the mitral and tricuspid valve. If you would like to see it from the back, simply rotate in the A plane around the y-axis, and go back again. From the back side. And now I would like to demonstrate how to show the septum in the rendered image. You simply start to rotate again around the Z-axis and move your green line very close to the septum, and immediately you can see nicely the rendered image of the septum. So I hope this will help you in your daily routine, and thank you for your attention.
Okay, that was a really beautiful demonstration of, in fact, one of the clearest demonstrations of STIC I've ever seen. So thank you so much for that, Roland. I think that Laura, what are your views on STIC? Do you use STIC? Have you been using STIC?
I try to use it whenever possible, but and the pictures shown in the demonstration are really amazing. The level of detail of the cardiac structures is just superb. The problem is that it's a lot of post processing and you need time to do these things. So that's the only handicap that I see with the technology. And when you have clinics that are very busy, it's difficult to get to do these things. But yes, I am looking forward to spend some time with the person who do the demonstration so he can teach me how to do these amazing things in my clinics.
And I'm trying to get a permanent probe, that permanent beautiful probe. But anyway, that's internal housekeeping issues.